break. So you'll have the opportunity to do that. Your quiz for Unit 3 will probably be on Friday. This is a multiple choice on knowledge. I'm going to do, for your assignments, I'm going to do an assignment with Unit 3 and Unit 4 combined. I'm not going to make one for each one because the units are short. So yeah, we're on Unit 4 now. After just 3 days on Unit 3, we're moving on to the reciprocal functions. So remember, it's 1 over x, that is the reciprocal function. So we're just going to get into the basic, how to graph them, what characteristics to notice, and just basically what the end behaviors are and where the asymptotes, vertical and horizontal, are going to be. So depending on how long this takes me, I might do 2 lessons, I might do 1. This one's a pretty long lesson only because you have to graph a lot. So when it comes to the reciprocal function, if you guys remember, our reciprocal function is 1 over x. So remember, we have an asymptote at y is equal to 0. And we have a asymptote at x is equal to 0. So we have a vertical asymptote at x is equal to 0 and a horizontal asymptote at y is equal to 0. Okay, so both graphs are in the same quadrants for the same x values. So if we take f of x, which is just the regular linear function, and its reciprocal, which is 1 over x, both of them lie in quadrant 3 and quadrant 1. When f of x is equal to 0, there is a vertical asymptote for g of x, which is the reciprocal, and f of x is always increasing. So remember, the linear function is always increasing. And g of x is always increasing. Okay, so when you go from left to right, it is always going down. Same with this other hop, going from left to right is always decreasing. Okay. So now we're going to take a look at other reciprocal functions and how we can apply what we know from 1 over x. So the first one we have is we're going to look at p of x is equal to x plus 2. And q of x is equal to 1 over x plus 2. So I already put these on Desmos, so we're going to take a look at them. So the first question is going to ask, where are the zeros and or vertical asymptotes? So if we look at the graph over here, so the line is obviously the red line is y is equal to x plus 2, and the blue graph is y is equal to 1 over x plus 2. So in y is equal to x plus 2, do we have any zeros or asymptotes?
Yeah.
Negative 2. And for y is equal to 1 over x plus 2, do we have any zeros or asymptotes?
Yeah. Negative 2 and 0.
Yeah. Oh, vertical asymptote, sorry. Where's the vertical one?
Negative 2.
Negative 2. So for p of x, we have our zeros at x is equal to negative 2, and it has no vertical asymptote. Q of x is 1 over x plus 2, has no zeros, but it has a vertical asymptote at x is equal to negative 2. Now the next question is based off the graph that you saw, which intervals on the graph is above the x-axis? So for p of x is equal to x plus 2, what intervals is it above the x-axis? Okay, and how about for q of x is equal to 1 over x plus 2?
Same thing.
Remember the asymptote above the x-axis. So remember we have a vertical asymptote at x is equal to negative 2.
Yeah.
Where is it above the x-axis?
Oh, yes.
From negative 2 all the way to
0. Negative.
positive infinity. because it keeps getting closer to 0, but it's still above the x-axis.
So it's anything greater than 0, or when x is greater than 0?
So this would be from -2 all the way to positive infinity. Now, what do you think the intervals on which the graph is below the x-axis is for both graphs? So let's look at x plus 2. Where is it below the x-axis? Where is x plus 2 below the x-axis?
-2.
So when x's are greater than or less than -2? Less than -2, and how about the reciprocal?
Negative infinity.
Yep. So for x is less than -2, and from negative infinity to -2. Okay, this one should be pretty easy just based off the equations. The intervals in which the graph is increasing for x plus 2. Always. So from negative infinity all the way to positive infinity. And is the graph increasing on the reciprocal? Remember, we always read it from left to right. No. So there's no intervals. How about in terms of decreasing? Is the linear function decreasing at any time? Nope. So there's none. And how about the reciprocal? What intervals is the function decreasing at?
Negative infinity to -2.
And then?
And then -2 to positive. Yeah.
So we're going to write that in interval notation. So we're going from negative infinity to -2 and -2 to positive infinity. Yeah, so this lesson is not about the graphing part yet. It's more about just the knowing the characteristics of it. So now we're going to look at where the points, where the y value is +1. So for y is equal to x plus 2, what x value is my y +1?
-1.
At -1, okay. So as you can see here, is at -1 and 1. And how about for the reciprocal?
Same thing.
The same thing. Now, next is where is my y value equal to -1 on both of these functions?
-3.
Yep, for one or for both?
Both.
For both. So as you can tell, the reciprocal and just the parent function, they both intersect when the y's are +1 and the -1. Okay, so as you can see over here, the parent function and the reciprocal intersect at -1 and 1, and also at -3 and -1. Okay, so what do you notice about the intervals of increasing and decreasing between the parent and the reciprocal? So we're just focusing on this section right here. Is there anything that you notice?
One's always increasing, the other's always decreasing.
So for example, in this one, P of X was always increasing, okay, while Q of X was never increasing. And P of X was never decreasing, while the reciprocal is always decreasing, okay? It's not negative infinity to infinity because it's usually the opposite. The only reason being is because we have that asymptote. So we have to take that into account. Okay, so now we're going to get into something, I guess, with more things going on in the graph. So we have our parent function. We have p of x is equal to x minus 2 times x plus 3. And the reciprocal is q of x is 1 over x minus 2 and x plus 3. So based off the equation for p of x, do we have any zeros or vertical asymptotes?
The first one?
Yeah.
Yeah.
P of x.
Zeros.
So zeros at
2 and negative 3.
x is equal to negative 3 and 2, and we have no vertical asymptotes. How about the reciprocal?
First class asymptote. The same.
Yep. All right, now we're going to take a look at the actual graph. So our first question is, what are the intervals on which the graph is above the x-axis? So let's look at p of x, which is just the regular parabola. At what intervals is the function above the x-axis?
X is less than 3 or greater than 2, or less than negative 3.
Okay, so we can say negative infinity to negative 3, and then from 2 to positive infinity. All right, now the next one's going to be a bit more trickier because we have a lot going on with the reciprocal. So where is the reciprocal above the x-axis?
Negative infinity. 3.
And
2 infinity.
yeah, so it's going to be the same thing as its parent function. All right, now we want to figure out where the graph is below the x-axis. So again, we're going to start with p of x, which is the red graph. Where is the graph below the x-axis? Okay, and how about the reciprocal?
Same thing.
Same thing. So both are from negative 3 to positive 2. Okay, now we have to ask ourselves, what are our intervals of increase? Remember, we're reading the graph from left to right. So for p of x, which is the red graph, where are my intervals of increase?
Negative half positive infinity.
Mm-hmm. So negative 1/2 to positive infinity. So for parabolas, the interval of increase usually comes where the vertex hits and then to the right of it. That would be the interval of increase. And for our reciprocal, what is our interval of increase?
Negative infinity, negative 3.
Mm-hmm. And what else?
Negative 3 to a half.
Not a half, but negative.
Oh, yeah, negative
0.5,
half.
right? So you have negative infinity to negative 3, and then negative 3 to negative 0.5. All right, now how about our intervals of decrease for our parent function?
Negative infinity or negative half.
Yep. And for the reciprocal?
Negative one to 2.
Yep. And then?
2 to infinity.
Yep. So we have negative infinity to negative half for the parent function as our interval of decrease. And then we have negative 0.5 to 2 in union with 2 to positive infinity. Okay, so remember, you're getting your answers based off just looking at the graph itself. You're not using anything really special. With this lesson, let me just see if someone has a question. Oh, so the 0.5 came from the so-called vertex of this graph. So if we look at this point over here, 0.5, that would be your vertex for the, what's it called? For the reciprocal of that function. So hopefully you see it, Jose. All right, and now we're just going to look at where our y value is positive 1 for the parent function and the reciprocal. So where is my y equal to positive 1 for my parent function? Well, it really doesn't matter because they're going to be the same thing. So obviously it's a decimal. So we have negative 3.193. And the next point is 2.193. And that's going to be for both the parent and the reciprocal. Let's just say 2.2 so I can round up. And it's going to be the same thing with the reciprocal. All right, and the last question is, where is the y value negative 1? So we're going to find negative 1, and it's at negative 2.791 and at 1.791. What did I say, positive 1.791?
Yes.
Do you hear this in history? Okay. So now what we're going to do is we're going to see if we notice any patterns. Okay. So we have our parent function y is equal to x minus 2 and times x plus 3, and our q of x is 1 over x minus 2 plus 3. So if we sub in negative 2 for our parent function, what is our x value at negative? What is our y value when x is equal to negative 2?
Negative 4.
All right. And how about a negative 1?
Negative 6.
Positive 1?
Yes, negative 4. 1.
Negative 4? And how about x is equal to 3? 6. All right, now because it's the reciprocal, if we sub in the same x values, what do you think our y values are just going to give back? So 1 over negative 1 over 4, negative 1 over 6, negative 1 over 4, and positive 1 over 6. So what do we notice about the y values, and why would this relationship be important? So let's go with the first part of that question. What do we notice about the y values between the parent and the reciprocal? Yep. So q of x is just reciprocal of p of x. So an example is if y is equal to 1 in p of x, then q of x is just 1 over 2. So it makes it just easier for us to graph using the equation, because all we have to do is literally just make the y values from the parent function p of x, and just use the reciprocal to find what the y values are for q of x. So how does knowing the positive and negative intervals and the increasing and decreasing intervals for p of x graphs help you draw the reciprocal graph of q of x? So what do we notice about the increasing and decreasing intervals? Or what do we notice about when the graph is above the x-axis and below the x-axis with the parents and the reciprocal? Are they the same or different? So we're looking at this part right now. They're the same. Okay, so positive and negative intervals where it's above or below the x-axis, those are generally the same. Okay, and what do we notice about the increasing and decreasing intervals? So as you can see here, just forget the asymptote. So in the parent function, you have negative 0.5 to infinity here. And for the decreasing, you have negative 0.5 to infinity on the reciprocal. For the reciprocal, the increasing is negative infinity. So forget about the asymptote to negative 0.5. But the decreasing in the parent is negative infinity to negative 0.5.
Same.
Not the same, but they're just the opposite of each other. Okay. So whatever is increasing in the parent function is decreasing in the reciprocal, and whatever is increasing in the reciprocal is decreasing in the parent function. So why are some of the numbers in the domain of a function excluded from the domain of its reciprocal function? And what graphical characteristic is of the reciprocal function occurs at these values?
Yeah.
Okay, so the reason why that now some numbers in the domain are excluded is because it is undefined in the reciprocal function. So those numbers are undefined. And as Adam said, these are known as the vertical asymptotes. So far, so good? No questions? Okay, so what common characteristics are shared by the reciprocals and the quadratic or parent functions? So looking at the charts, what are some characteristics that are shared by the reciprocal and its parent or quadratic function? We already discussed some of them with the last two questions that we answered. So the first one is the zeros are the asymptotes. Mess it up. What else did we come to figure out?
When y is 1, we have the same x value.
Yep. When the y value is plus and minus 1. Anything else? So the parent function here has a minimum, okay? What does this reciprocal function have?
Maximum.
Maximum. So if f of x has a min, then 1 over f of x has a maximum. Okay, and what we said from the previous question, so the plus and minus intervals are the same. Okay, and what we figured out is when, say, f of x has an increasing interval, then 1 over f of x is decreasing, and vice versa. Okay, and we kind of touched upon this before. So why are the points where the y value is plus or minus 1 important? What happens to the reciprocal and the parent function at that those specific y values? They intersect. So hopefully this helps you guys plot out these graphs when we actually learn how to plot them without using the technology part of it. All right, so we are going to consider the function f of x is equal to f of x is equal to 2x minus 1. So for A, we want to say the domain and the range of the parent function, the x and y intercepts, the positive and negative integrals, the increasing and decreasing intervals, and then we want to graph 1 over f of x. So to graph f of x equal to 2x minus 1, what is our y-intercept?
-1.
So -1. And what would be our x-intercept?
Over 2.
1 over 2. And now, because we have to know this, at what x value does it give us positive 1 and negative 1?
The 1.
So 1 plus 1, 2, so x is 1. So at 1 and 1. And how about for x is -1?
What?
I'm sorry, for y is -1.
0.
Yep, so that's our y-intercept. So this is what our graph would look like. So we're going to focus on f of x is equal to 2x minus 1. So what is our domain and range for this function?
PR.
Okay, that's our domain. Yep. So we said our x-intercept or y-intercept is 0 and -1, and our x-intercept we said was 1/2 and 0. Okay, where is the graph above the x-axis?
1 is it?
Okay. So positive interval, we said from 1/2 to infinity. And how about the graph being below the x-axis or the negative interval?
-1/2.
Yep. Then we have D. So our intervals of increase and decrease. So where's our interval of increase?
Always.
Yep, so from negative infinity to positive infinity. Do we have an interval of decrease? No. Okay, perfect. So now what we want to do is we want to graph g of x is equal to 1 over f of x, which in this case, g of x is going to equal 1 over 2x minus 1. Okay? So where we see our x-intercept in the parent function, what does it turn during the reciprocal function? What does it turn into? Now, what does the x-intercept make in the reciprocal function?
2.
So remember, our x-intercept is when the y value gives us back 0. But if we have 0 in the denominator of any function, what does the function usually give us?
0.
undefined. So at the x-intercept of the parent function is our asymptote for the reciprocal. Okay? And because we know that the parent and the reciprocal intersect at y is equal to positive and negative 1, we can just make a rough sketch of this graph. And that would be our f g of x is equal to 1 over 2x minus 1. So now we have to answer all those questions again for g of x is equal to 1 over 2x minus 1. So what would our domain be and our range be for our reciprocal function?
CR X cannot be, or it has to be greater or less than 0 or greater than.
It just doesn't have to equal 1 over 2.
Oh.
Right?
Yeah.
Because at 1 over 2, our denominator is 0, and we can't have that as our denominator because it will just be undefined. So how about our range? So we have YER such that, what does the Y value never hit?
Zero.
Yep, so Y cannot equal 0. Do we have a y-intercept for our reciprocal function?
Yeah.
Okay, where is it?
1.
So 0 and negative 1. Do we have any x-intercepts?
No.
No. No x-intercepts, but we have a vertical asymptote at x is equal to 1/2. So in our reciprocal function, where is the graph above the x-axis?
When it's greater than 1 over 2.
Yep, so 1/2 2.
Positive.
Okay. And when it's below the x-axis,
Negative infinity to 1 over 2.
and the last thing is our interval of increase and decrease.
It's never increasing.
Okay,
And it's decreasing from negative infinity to positive.
never. And interval of decrease. Remember, for the interval of decrease, we always have to keep in mind the asymptote.
Negative and half.
So you have negative infinity to 1/2 in union with 1/2 to positive infinity. So whenever there's an asymptote and your reciprocal is 1 over a linear function, you're always going to have that union sign for your interval of increase or decrease, depending on what is happening, okay? Because the asymptote, you can't really count it as a point because it never touches that point, okay? So this is how you would graph a reciprocal linear function. Obviously, we did a example before with a reciprocal quadratic function, which is what we're going to do next. Me personally, I'd rather do synthetic division and long division than these reciprocal functions, only because they can get confusing at times. So we're going to do the same thing. So we have our function, f of x is equal to 4 minus x squared. So again, we want to state the domain and range, the x and y intercepts, the positive and negative intervals, so where it's above or below the x-axis, the increasing and decreasing intervals, and we want to graph its reciprocal function, so g of x equal to 1 over x. But what we want to do first is we're going to graph our parent function, f of x is equal to x squared. Oh, f of x equal to 4 minus x squared, sorry. So what would our y-intercept be? Or in this case, our vertex? 4. So 4. What value does our original function give us back? Positive and negative 1. But before we do that, can we factor this function out to give us our x-intercepts? Yeah. Okay, so what we're going to do first is we're going to rearrange it to write negative x squared plus 4. So what can we factor out to make it a difference of squares? Negative. So we get x minus 2 and x plus 2. So this is a parabola that is opening downwards. I'm just going to check where this graph is equal to 1. Negative 1.7. So what is our domain and range for f of x?
XER.
Right, because it's just a parabola. And our range?
Y, that Y is less than or equal.
Yep. Okay, we already answered this. What's our y-intercept? 0 and 4. And our x-intercepts, because of the difference of squares, we have negative 2 and 0, and 2 and 0. So at what point is the graph above the x-axis? Negative 2 and 2. And at what point is our graph below the x-axis.
Negative infinity and negative 2.
Okay.
2 to the positive.
Again, we're not doing anything hard here. We're just looking at the graph. And where is the graph increasing? Where's our intervals of increase?
Negative infinity to 4.
Negative infinity to 4. Well, negative infinity to what? Not 4. We're looking at the x values.
Oh. 0.
Yeah, 0. And our interval of decrease,
0 to positive.
0 to infinity. Okay. So now that we have that information for our function f of x, now we want to graph g of x is equal to 1 over 4 minus x squared. So where are our asymptotes going to be?
Negative 2.
Okay. Okay. And then we have an asymptote at 0. Okay. Now the quadratic ones are a bit more difficult to draw, depending on if it's a downward opening parabola at the beginning or at the end. Okay. So if our y-intercept for f of x was 4, what would it be for g of x, the reciprocal? What's the reciprocal of 4?
1 over 4.
1 over 4. So remember, if f of x has a max, g of x is going to have a minimum. Okay? And now we need to check where y is equal to positive and negative 1. So we need to check y is equal to positive and negative 1. So we don't need to use the reciprocal. We can just use f of x. So 1 is equal to negative x squared plus 4. Okay? So we move the 4 over. 1 minus 4 is equal to negative x squared. Divide both sides by, so we have negative 3 is equal to negative x squared. Divide both sides by negative 1 to get rid of the negative. So we get x squared is equal to 3. Take the square root. And x is equal to plus or minus root 3. So what does plus or minus root 3 give us?
1.73.
So positive 1.73. So we have it over here. And negative 1.73, we have it over here as well. Okay? So now we're able to draw one part of the reciprocal. So it's literally going to be a skinny parabola bounded by the asymptotes. But we're not done yet. We need to figure out where what x value gives us y is equal to negative 1. Okay? So as you can see, it makes sense. So the parent function had a maximum. this g of x has a minimum. So now we're going to check for -1. So we have -1 is equal to 4 minus x squared. So 1 minus 4 is equal to -x squared. -5 is equal to -x squared. Divide both sides by -1, and we get x squared is equal to 5. So we get x is equal to plus or minus root 5. And what number does that give us? 2.2. 2.2. So you have positive 2.2 and 1. And we have negative 2.2 and 1. So again, I'm just estimating it here. Not really up to scale, but I will show you on Desmos that this is what it's going to look like. So because it's on the inside of these, on the outside of the asymptotes, it's going to look like the 1 over x reciprocal function. And that's what your reciprocal graph is going to look like. So it's the graph in green. Does this look confusing? I have some people saying no, some people say yes. So what's going to help you graph the reciprocal is this part right here. Where the graph intersects at y is equal to plus or minus 1 is going to help you determine how to draw your graph. Okay? So for example, here, we determined that we have x is equal to plus or minus root 3, and that's where it's going to intersect at positive 1 in the y value. So you have plus 1.73 and minus 1.73. Okay? And we also figured out that -1 happens when the x value is positive or negative root 5. Which line are you talking about, Juliana? You can unmute your mic if you have one.
Like the 1 minus 4 equals x squared, like the line after that, it goes to negative x squared.
Oh, because I forgot to carry over the negative on the line previously. So that was my mistake.
Okay.
So I'm going to plot this in on Desmos, and you guys are going to see that it should give us back what we just did. So you get y is equal to 1 over 4 minus x squared. So what were the key points that we're looking at? So we have 0 and 1 over 4. Okay, remember our y-intercept was 0 and 4. So the reciprocal of 4 is just 1 over 4. Okay, and we calculated where y is equal to positive 1, and that happened at 1.732, or positive root 3, and negative 1.732, or negative root 3. And then we figured out where our y is equal to -1. So that's 2.236, which is positive root 5. And then negative 2.236, which is negative root 5. Okay, so as you can see, both of these look, Desmos is obviously nicer. Mine is just a rough sketch. So we're going to answer the domain, the range, the x and y intercepts, and the positive and negative intervals. So what is the domain and range for our reciprocal function?
X here, but X doesn't equal negative 2 or 2.
Yep. And what is our range?
Y are set Y cannot equal 0.
Yep. So do we have any X-intercepts in our reciprocal? None. And what is our Y-intercept?
0 4.
Yep, 0 and 1 over 4, which is just the reciprocal of f of x. So where is the graph above the x-axis?
Negative 2 to 2.
Which is the same thing as the parent function. And where is the graph below the x-axis?
Negative 2.
Mhm.
In union with 2 to infinity.
Yep, which is the exact same thing as f of x. So where's our interval of increase for the reciprocal?
0 to 2
Mhm.
and 2 to positive.
So remember, we're reading graphs from left to right. So all Matthew did was he looked at the graph from left to right. So from 0 to the asymptote 2, it's increasing. And from 2 all the way to positive infinity, it's increasing. Okay, so it's going from down and it's going up. So what is our interval of decrease?
Negative infinity to negative 2. And 2, negative 2 to 0.
Yep. And negative 2 to 0. Okay. So we have one more example. It's just we're going to take a parent function f of x, and we are going to transform it into its reciprocal. Okay, just given the stuff that we learned. So I'm just debating if I want to do this next one because I don't want to jam too much information for one day.
Like lesson.
Pardon? Yeah, because it has to do with horizontal and how to find horizontal asymptotes given. So I think, is this enough for one day? Are you guys like brains just exploded? So for the last one, we are going to sketch a graph of the reciprocal function given this graph over here. So we need to jot down some key points, okay? So our first key points, what is our, I guess, maximum in this one?
Negative 0.3.
So negative 4 and 3. What are our x-intercepts?
Negative 5.5 and 2.5.
Yep, so x is equal to negative 5.5 and x is equal to negative 2.5. Okay. So we want to graph the reciprocal. So we have f of x, and we want to graph 1 over f of x. So the first thing that we should do is draw our asymptotes. Okay, so where are our asymptotes going to land for 1 over f of x?
Negative 5.5 and negative 2.5.
So remember, the asymptotes, the vertical ones, just have to do with the x-intercepts of f of x. So we have it over here. Let's see if I can draw it properly. Okay. And at 5.5. Okay, and automatically we have one at f of x is equal to 0, at y is equal to 0. Horizontal asymptotes, we'll learn how to figure them out in the next lesson. Okay, it just has to do with the numerator and the denominator of the function. Okay, so now that we have our vertical asymptotes and our what's it called? Our maximum. How do you think we're going to be able to draw this graph?
Where y is equal to positive.
Okay, and where would that? Yeah. So as you can see, it already gives it to us here. So we have a negative 2 and 1, and at negative 6 and 1. Okay, so automatically, because it is outside of these two asymptotes, this part of the graph is just going to look like 1 over x. Okay, and because we have a maximum in f of x, what is our reciprocal going to have? A minimum of negative 4 over 3, and what's the reciprocal of 3? 1 over 3. So remember, this is just the reciprocal of 3. And as you can see, it already has positive 1 given to us. So that happens at negative 3 and 1, and at negative 5 and 1. So does it look similar to what we did in the last one? Okay, so what parent function did this correspond with?
Absolute value.
Absolute value. So absolute value and quadratic will generally have the same reciprocal function. Okay, linear is the easiest one to draw because it's just the 1 over x. If this was opening upward, the reciprocal would just be flipped. Okay, so you would have these two on the positive x-axis and this mini parabola in the negative x-axis. Okay. So I want you guys to practice this, and I want you guys to ask me questions because this is probably the most annoying part of Unit 4 is drawing these reciprocal graphs. Remember the key points you need to look at is the max or min of the parent function f of x, where y is equal to plus or minus 1, and the x-intercepts. These three things will help you draw a reciprocal, okay? So I want you guys to, I guess, take your 15-minute break. And after the break, I want you guys to start working on the homework. If you guys have any questions from the homework and you want me to do one example with you guys in class, I'll be more than happy to do so. You guys in cohort A, you guys can check the solutions to the assignment, which I have over here. And I will upload those on the weekend, or before the weekend. Hopefully I can get them marked by Friday, so I can just post these up. So tomorrow we're gonna do, what is it, 4.2 and 4.2, and Friday we will do 4.3 and 4.4. Okay, so you have your homework on the course on our Google Classroom. So practice this, okay? I know it seems hard, but once you get used to it, it's not that bad, okay? So just look at your homework syllabus thing and start doing the homework questions, okay? And then if you have questions about this, just come up and ask me and I'll help you, no problem. No, I want you guys to practice this because some of you are confused, and I just want you guys to ask me questions about this lesson when doing the homework.